All right, let's take a look at 11.2. We're starting to do some 3D figures. So we need to name them first, figure out what we're talking about. So a prism, kind of like a box, is a solid with two bases that are congruent and parallel. The bases would be the top here and the bottom here because they're parallel and they're congruent. The other sides are not parallel, they intersect. So this is a triangular prism because the bases are triangles. We move over to pyramid, solid with one base, which is right here, and faces that meet at a point. Obviously, that's there. The figure is a triangular pyramid because the base is a triangle. The triangular pyramid, we name it by the base. A cylinder, well, cylinder is just a cylinder. It's a can. Prism with circular bases. Then a cone is a pyramid with a circular base, but we know what a cone looks like. Usually we have it the other way around and eat an ice cream out of it, but okay. A solid or a sphere is a solid in which each point is equidistant from the center point. It's a ball. There's not really a base, although we maybe use this middle kind of segment, but we're not going to deal with spheres this year. So now we're just going to name them. We're not going to calculate anything, just name them based on what they look like. So number one, obviously it's a pyramid. I hope that's obvious. Comes to a point. And the base is a rectangle. So this is a rectangular pyramid. Number two, well, that's pretty straightforward. That's a cone. Got the circular base. And then, again, the point, or it meets at a point. Number three are bases, two things that are congruent. So this is a triangular prism. Same thing as what we looked at above. Now we have number four. It is a pyramid. We got to figure out what our base is. It's all of this. So if you look at it, we got 1, 2, 3, 4, 5, 6 sides. Hopefully remember a six-sided figure is called a hexagon. So this is a hexagonal pyramid. Just named by the base. Of course, number 5 is cylinder. Bases are the two circles. Number 6, the base, and the base, although many of them could be bases. This is a rectangular prism. Moving right along. So number 7, the bases are the two congruent faces. So that would be here and the back part here. Now what are those bases? They're trapezoids. So this is a trapezoidal prism because they're just connected by their vertices. 8, we can tell this is a square in the base because we have all the 4 right angles and the 4 sides are all congruent. So this is a square pyramid, again, because it comes to a point. Number 9, we got a base here, and we got a base here. Now, what is that base? Well, there's 5 sides, so this is a pentagonal something. On those two faces, or bases, are connected by just sides, so that is a pentagonal prism. And then to finish this off, number 10, well, our base is down here. So this is triangular something. That's our base. And it's a pyramid because, again, it comes to a point. Number 11, we got the base, we got the base. They're two congruent sides and parallel. So again, this is a triangular prism. And of course, number 12, hopefully is very obvious. It's a sphere. So that's how we name them. Now, we're going to find surface area. So, surface area is the area of all the faces. So if we were to paint these figures, this is the area we need. So for rectangular prisms, or cubes, which are, I guess, square prisms, our surface area is 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. It's each measurement multiplied by 2, and then we add them all up. So for number 1, it doesn't really matter what the height, the length, and the width are, but just for argument's sake, let's make the width be 7, the length be 13, and then the height be 9. So our surface area is equal to 2 times our L times our width plus 2 times our length times our height, whoop, that's a 9, plus 2 times our width times our height. So we throw that all in Desmos or the calculator, and we should get 542 feet squared. Since we're talking about area, these are all going to be units squared, whatever the units are in the picture. All right, number 2. Still a rectangular prism because we have a rectangle here. And again, it doesn't matter what the length or the width or the height is. Let's make 5 the height, 16 the length, and the width to be 10. Again, it doesn't really matter. So we're just looking at our formula over here. 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. So again, we just throw that in Desmos or our calculator. We get 580 centimeters squared. Now, if you didn't get that, make sure your calculations were correct. Maybe you wrote it down fine, but you mishit something. We got one more of those rectangular prisms. So number 3. Again, it doesn't matter what length, width, or height is. I'm just going to make these our dimensions. So our surface area is 2 times our length times our width plus 2 times our length times our height, 1.5, plus 2 times our width, 6, times our height of 1.5. Again, we throw that all in our calculator or Desmos, and we get 183 inches squared. Don't forget the square. That's how we find it for rectangular prisms, or cubes, which are still rectangular prisms. Now, all other prisms, it's a little bit more general. So this is saying find the lateral area first. You don't need to do that. Then add the area of the bases. So the lateral area is h times p. It's not Harry Potter. H is the height between the bases. P is the perimeter of the base, the distance all the way around the base. And capital B is the area of the base. So again, we don't need to really worry about that one. I'd focus more on that one. So number 4, first of all, let's find our bases. Base is here and here. So surface area equals our height, which connects the two bases, so that's our 16, times the perimeter of our base. So that means around this triangle. This, and this. We know that's 9, that's 12, and this side, labeled down here, is 15. So the perimeter of our base is 15. Oh, not 15. Sorry, we got to add those up. Silly me. So 12 plus 15 is 27, plus 9 is 36. So that by itself is our lateral area. If you want to find just the sides, no, that's not, yeah, that's our lateral area. Now to find our base area. So it's 2 times the base area. Well, our base is a triangle, and if we draw it out, that's a horrible triangle. 15 was our hypotenuse, 9 and 12 were our 2 legs, and it is a right triangle. So when we want to find the area of a triangle, remember that it's 1/2 base times height. Well, here the base and the height always make a right angle. So the base and the height are 9 and 12. Which is which? It doesn't matter. So we'd have 1/2 times the base times the height. So notice we have 2 times all of that, but within that we have 1/2 times 12 times 9. So again, we just throw that all in Desmos. We get 684 not centimeters, meters squared. All right, there we go. So it's just plugging stuff into formulas. We just gotta remember what formulas we're talking about and what those things mean. So if we look at number 5, the 2 bases that are parallel and congruent are the front here and the back. Now, because that's kind of crazy, I'm going to erase the back one. So surface area is the height, which is the length that connects the 2 bases. So it's here. So it's 3 times the perimeter of the base. So we got to add up the sides again. So we got 12, 5, and then this is 10 because we got a rectangle here, so it's got to be the same. 10 plus 12 plus 5 is 27. And that's our perimeter. That's our P. And plus 2 times our base area, which again is a triangle. So it's 1/2. The base, remember that's where they make the right angle. It doesn't say that the right angle is here. Because in fact, it is not. It is going down here. So the height is actually 4.1. Then our base will be the one that makes a right angle with it. It's really the back side. But it's the same as the front because it's a rectangle and we get 12. Again, we throw that in Desmos or our calculator and we get 130.2 kilometers squared. All right, let's keep going. We'll get a little bit crazier as we go on. So now we have this figure, number 6. The 2 sides or faces that are congruent are the front here and the back. But again, just so we can see it a little bit better, I'm going to erase the back one. So what kind of shape is that? Well, that is a trapezoid. Because we have this line parallel to this line. We have a right angle, but we don't have any congruent sides. So it's a trapezoid. Okay, so our surface area equals our height, which connects the two bases, so that's 15. I think that's a 15. Times the perimeter. So we want 23, 12. We're going to have an 18 here because it is the same as the back base or back face. And then this, just like what we just talked about, if this is 20, so is this. So we got to add up those four sides. 12 plus 18 is 30, plus 20 is 50, plus 23 is 73. Just those four sides added up. Then plus 2 times our base area. Well, now we have a trapezoid as the base. Now we got to remember what our area of a trapezoid formula is. It's 1/2 the height, and not times the base like we have in triangles, but there's 2 bases. So it's base 1 plus base 2. So if we're writing the area in here, we got 1/2. The height we already said was 15. And then the bases. Well, the bases are the ones that are parallel. So it's this line and this line. So that's 18 plus 23. Close it up. Multiply all that out. Throw it in decimals. Throw it in your calculator. And we get 1,587 feet squared. That is a big trapezoidal prism. So keep on trucking. We got a couple more before we get into a different shape. So that'll be exciting. Well, again, we have a trapezoidal prism. We have the faces, or the bases, and then the one on the other side, the back side. But again, I don't want to color it in and make it confusing. So even before we start doing some stuff, let's label these sides. These are congruent, so this has to be 13. This is 10. We got 9 going across. This top base is 18. And the bottom here is 10. I don't know why I wrote that again. And this side's 3 because it has those tick marks. So we know both those sides are equal. So, surface area is same formula that we're dealing with before. I'll write it out again, so hopefully we can remember it a little bit better. It's height times the perimeter of the base, plus 2 times the area of the base. So our height is what connects the two faces. The two faces are trapezoids again. So this is our height, the 9. So it's 9 times the perimeter of our trapezoid. So 10, 3, oops, not 3, 13, 2 13s, an 18, and a 10. So when we add all those up, we get 31, 44, 54. So that is our perimeter of the base. Plus 2 times our base area. Well, the base is a trapezoid again. So trapezoid is 1/2 height times base 1 plus base 2. And it doesn't matter which one's base 1 or base 2. We just have to make sure we have both of the bases. So we have 2 times 1/2 times our height, which we already found was 9. And then our base 1, base 2, again, doesn't matter which is which. So 10 and 18. Because those are the sides that are parallel. That's what those little arrow marks mean. So we got a long thing here, but just throw it in Desmos, throw it in your calculator, and we get 833.2 millimeters squared. Whoops, that is not correct. So the mistake that I made, and I did this to prove a point, the height of our trapezoid is not 9. That's the height of our prism. The height of our trapezoid, maybe get rid of all this stuff. The height of our trapezoid is this distance here. It makes a right angle with one of the bases. So it's 12.4 there. So now when we multiply it, we will get 833.2 millimeters squared. I apologize for that. Moving on down to number 8, last one of our prisms. We have a triangular prism. Our bases are triangles. So again, let's start our formula. We need our height, which connects our two bases, so that's 21, times our perimeter. We got 15, we got 8. We don't know what this other side is, but that's a right triangle, so we can do Pythagorean theorem. So that's our hypotenuse, so it'll be 8 squared plus 15 squared equals x squared. So that's 64 plus 225 equaling x squared. That's 289 equals x squared. We square root it, and x is 17. So that is our hypotenuse, our missing side there. So now we can find the perimeter. We got the 15, the 8, and the 17 for a grand total of 40. Let's see. So the perimeter of the base is 40. Then plus 2 times the area of the base. Well, the base is a triangle, so it's 1/2 height times the base. And those are the two sides that makes a right angle. So that would be the 15 and the 8. And we multiply those with 1/2 multiplied by 2. Obviously, the 2 times 1/2 basically cancel out, so we're just multiplying 15 times 8 and adding it to 21 times 40. So when we throw that all in our calculator and or Desmos, we get 960 inches squared. Again, don't forget your units. All right. We will finish up with some cylinders and a couple of word problems, and then we'll call it a lesson. So now we have some new formulas. We have our surface area formula, which is what we need. I don't really care about the lateral area. So now we have pi in our answer. So if we want exact answers, we got to keep pi there. If we want approximations, which is probably what we're gonna want, we multiply the pi in there and get decimal answers, and we'll have to round. So if we're looking at number 9, surface area equals 2 times pi times r, which is the radius of the base, radius of the circle, which is 11, says it right there, squared, plus 2 times pi times our radius again, and then times our height, which in this case is the 26. It connects the two bases of circles. So if we were to multiply the 2, 11 squared, keep the pi, 2 times 11 times 26, keep the pi, and add those together, we get 814 pi yards squared. Now if we want a decimal approximation, which is what we're going to want. We do 814 times pi, and we get 2557.26 yards squared, approximately. Again, we had to round, so it's not exactly. Okay, we got another cylinder here. Surface area equals 2 times pi times our radius. Oh, but be careful, that 15 is not our radius. That 15 is our diameter. So we got to do that and cut it in half. And that will be our radius. 7.5 is our radius squared plus 2 times pi times our radius again of 7.5 times our height, which connects the two circular bases, of 9. Of course, we throw it all in Desmos, our calculator, all that. We get 247.5 pi. But when we multiply the pi in there and get a decimal approximation, we get 777.54 meters squared. So that's how we find surface area of a cylinder. Now we got 2 word problems. Okay, we got a prism and we have a cylinder. So let's rewrite those formulas here. So a prism surface area is going to be the height times the perimeter of the base plus 2 times the area of the base. Whereas our cylinder here, well, it's the same as what we were just doing up there. Surface area equals 2 pi r squared plus 2 pi r h. But in these problems, we're not just finding surface area. We're actually working backwards with the surface area to find the measurement. So we need to find the length in this first one of this cereal box. We know the surface area is 272. So again, we got to work backwards. So the surface area, so let's call the top of the box and the bottom of the box our bases. And since this is a right, we won't do that. So surface area is our height, which is 12, that's connecting the top and the bottom of the boxes, our bases, times the perimeter of our base, which we don't know. We got a 2, there's a 2 on the other side, but then we have L and L. So 2 plus 2 is 4 plus 2L. Then plus 2 times our base area, which again we don't know because we don't have our length, so it'd be 2L. Now we need to distribute 48 plus 24 times L plus 4L. We can add up our like terms. So 48 plus 28L, can't add those, they're not like terms, equals the 272 inches squared that is our surface area. So we subtract 48. We're left with 224 equals 28 times the length and divide by 28. So our length equals 8 inches. And we can always work forwards and check that. But we're not going to right now. Now, number 12, last one. The surface area of the soup can below is 51.84 inches squared. The diameter of the can is 3 inches. Find the height of the can. So they didn't give us a whole lot. We need to find the height. our diameter is 3. But we don't want that. We want our radius. So if our diameter is 3, we divide that 3 by 2, we get 1.5, and that is our radius. So we set up our formula. Surface area, which in this case is 51.84, equals 2 times pi times our radius squared, so 1.5 squared, plus 2 pi times our radius, now times our height, which we don't know. We can't go any farther than that. So let's simplify what we can. When we multiply out the 2 pi, 1.5 squared, we get 14.14. 2 times 1.5 times pi is about 9.42 h. And then we just solve this like a regular equation. Subtract 14.14. We get 37.7 equals 9.42 times the height. And we divide by 9.42. So h is approximately, because of rounding, I'm sure the surface area is rounded, is approximately 4 inches. And it's not squared, because it's just a measurement, it's not the area. That's how you find surface area.